All right. Quick background about me. I think, as is already mentioned, I run a couple of security conferences. I'm an author of few of the open source software out there. I'm going to talk about the Exploity framework, which is one of the latest ones that I've worked on, and and I'm a trainer and speaker at various cybersecurity conferences. So let's run through kind of a story on cybersecurity in general from the 90s, late 90s to the last decade. And what basically I'm going to be talking about is the difference in terms of how complex the infrastructure and the technology was, and as time progressed, what are the things that came to be. And where do we stand in terms of cybersecurity as a whole, mostly from an enterprise perspective. So let's start with the late 20th century. There was a young and dynamic cybersecurity professional who was tasked with keeping his enterprise or employer's infrastructure safe. In the 90s, the infrastructure or IT infrastructure, as you would call it, would typically mean something like this, where you have servers, you have networking equipment, you have firewalls, and then you have client machines, and pretty much that. And bad guys and researchers at the same time were coming up with a lot of security vulnerabilities, specifically around native applications, servers, as well as web applications. So this guy, he had his fair share of nightmares, but as time progressed, as we approached the 21st century, we were in terms of, we had knowledge of software security, more specifically around application security, web application security, native application security. There was plethora of information available on the internet about how do you go about writing secure code for web applications, for native applications, and so on and so forth. So we felt pretty secured at that time. Fast forward a bit to the 21st century. The same guy, well, not so young, was again tasked with securing his employer's infrastructure, which typically meant, obviously, we still have the typical IT infrastructure, which includes servers, networking equipment, client machines, desktops, laptops, but as time progressed, people started getting these interesting devices with them to office, and these were pretty powerful and pretty smart. That gave some nightmares to our friend here, and then the industry came up with BYOD policies and this and that, and by this time, these handheld devices were pretty powerful, and as powerful as a desktop or a laptop. Again, as time progressed, this thing called cloud came, and we had cloud providers like AWS, Google, and enterprises started thinking, instead of managing everything in our infrastructure, why don't we push some of the data as well as processing over the internet to the cloud? That could save us, a lot of work in terms of managing the infrastructure, and more importantly, securing the infrastructure. So as time progressed, a lot of data went to the cloud, but it was good for the enterprise, but it was not too good for our friend here, because then people started using cloud for within the enterprise for a lot of different things, and that gave birth to shadow IT as we see it. Now, if you ask an enterprise, what is your footprint over the internet, that is in itself one of the service streams in cybersecurity, to identify what is the footprint across the internet for a specific enterprise. But then, more specifically in this, the last decade, lot of innovation happened in terms of hardware. So the hardware became accessible. More specifically, after the mobile smartphones, became mainstream, people started creating cheap hardware. So what happened was, a lot of people could prototype on these hardware and create solutions which we had never seen before. Think about smart toothbrush. I don't see a use case for smart toothbrush, but it is inevitable. People are going to use everything today is just going to be smart. So when you talk about even enterprise security, it's no more about looking at server security, looking at networking equipment or router security. We've gone much beyond that now. Everything is connected. I mean, you can do an exercise when you go back or go about your day. Just look at things which are automated around you, even in your home, and I'm sure you'll be surprised to look at the amount of automation and the amount of devices that you have around you. And this is not going to stop. Everything is automated. Fine. Eventually, these machines are going to get inside humans as well. So the challenge here is really about identifying these devices which are in an enterprise, and B, looking at vulnerabilities on these devices. So if you compare devices which are used for critical operations, more specifically around medical, critical infrastructure, automotive or transportation as a whole, aviation, it's no more about doing these James Bond style hacks and getting persistent access to a desktop, exploiting a native application. With these devices placed in critical areas, doing critical operation, all someone needs is a vulnerability which can cause malfunction on the device. So that can just plainly, let's say, denial of service. That's enough to cause damage, and this damage, is way more worse than the damage that can be caused by somebody hacking through your browser into your laptop and stealing data. Right? We're talking about physical damage here, loss to life as well as property. So yeah, he started having nightmares again. The only thing that changed was the nightmares also upgraded themselves. So as far as the new technology is concerned, IoT, AI, hardware, we are not there yet. There are no specific guidelines or standards. There are standards which are coming up, but there are no tried and tested standards as of now which can guide hardware manufacturers across various verticals, specifically from cybersecurity perspective. There are standards available which talk about functional safety for medical, for automotive, but there are no mature standards which talk specifically about cybersecurity. So I think it's going to probably take at least 5 years or a decade that these standards will mature. And so let's look at what the challenge is. So when we specifically talk about Internet of Things, it is not a single line of technology or not a single technology that you can secure against, because if you look at IoT as a whole, it is a mix of various technologies. We have the hardware, we have RF communication, we have AI, we have cloud, we have mobile applications. So all of these combined. So if you want to create an IoT product today, you probably need to implement all of these things. Implementing is still not as difficult, because you typically will take hardware from a hardware manufacturer. There are companies who will design the hardware for you, and your job is to just put your firmware on the device, which is your business logic. There are frameworks available there where you can deploy your application on the cloud quickly. You can create your mobile application which can communicate to the cloud and the device. So all of that is not challenging. The problem is the attack surface is really huge. And when you are going to pen test or do risk assessment or security assessment for even a single product, let's take a very simple example. Fitness watch, smart toothbrush, whatever. It has hardware, it has firmware, it has Bluetooth communication, it has a mobile application, it also has cloud application and cloud analytics. How do you secure this? I mean, I have never found a single person who can effectively do a security assessment for one product, because you will have experts for cloud who do not know anything about firmware. You will have experts for hardware who have no clue about cloud and mobile application. The second issue is supply chain. Now, all of these things are through third party. There's no vendor as such that can create a product from grounds up. Simple example, automotive, right? You get parts from everywhere, you assemble the parts, you create the design, or let it be any product for that matter. So there is a supply chain when you are creating a product on your own. What are the security repercussions of the third party components that you are putting in? It's just a contract between you and the third party vendor. At most, what you can do is force them to get risk assessment and security assessment done, which is not at least enforceable by law. So yeah. So if you want to do rapid prototyping, you want to reach the market fast, you will bypass some of the steps in your software development life cycle. Then is regulation and compliance. As of now, there are not many regulations, and the regulations are coming up. For example, you have the California IoT Security Act. You have HITB that has come up with a standard for consumer IoT. You have, I think, I forgot the number, but there is a standard coming up for automotive as well. And there are a couple of ISO standards, 27400, 27402 for IoT security and privacy, but they're still under the works. But as soon as they come, they're going to drive at least manufacturers to get themselves verified against these compliance standards. And then there are obviously standard threats and risks like weaponized malware. We are already seeing a lot of malware specific to IoT. I wouldn't call it an IoT malware, because they are pretty standard malware targeting standard devices like routers and cameras. We haven't seen sophisticated malware as of now, which attacks embedded OS or bare-bone firmware yet. But I mean, again, that is inevitable. As more devices will come, people will find more ways to exploit these devices. And on one of the challenges in these in the IoT technology is that if the vulnerability is in the software, you can patch it. But if the vulnerability is in the hardware, then there is absolutely practically no way of patching that. So what the vendor needs to do is do a product recall, which itself is a huge cost to the vendor. So if you are a startup or even a funded startup and you have to do a product recall of millions of products deployed across the world, I think you will be pretty much shutting down your shop the next day. All right. So we also learned the hard way, as in we started looking at IoT security somewhere around the early last decade, and we got really interested with all these gadgets, and we started researching on embedded security, IoT security. And we've been doing software security for a long time for our customers. So we thought like, hey, we're like a bunch of hackers. We can, we can hack anything. Just throw that at us. The only difference is that the target is changing, right? The approach on how you go about looking at doing threat modeling and looking at ways to bypass certain security measures more or less remains the same. I mean, that's true to some extent, and we were like, just throw anything at us and we're going to beat the crap out of it. But turns out when we got into IoT pen testing, when we started doing pen testing for customers from one product to another, this is what happened. Effectively, for every product, for every component of the product, there is a separate tool, hardware as well as software, that you need to use. And the interesting aspect is that there are no standardized commercial solutions that can help you with this. Coming back to even our example of a small smart toothbrush or fitness band, you still need something where you can effectively analyze BLE communication. You need something where you can access the hardware, and then if it's using if the mobile application is using any other new IoT protocols, you would need something else. So what we did was, and then when you move from one product to another, so you were doing BLE here, the next product that you see has ZigBee. The next product that you move has Z-Wave, has wireless HART, has something else. The hardware is different, obviously. The chipset will be different. It will be implementing some industrial IoT protocols. Something will be implementing medical protocols. Something will be implementing standard IoT protocols. And the problem is, then you look at open source. There are hobbyist open source software projects as well as hardware projects available. But when you get into security assessment, what happens is you end up basically working on these open source tools. And at times we were really frustrated that we started everything from scratch, or we ended up changing a lot of things in the open source hardware, creating small hardware tools for specific jobs. And yeah, so we were spending a lot of time to learn how to use a specific technology, to learn a specific tool, which we are not sure whether we are going to use in the next security assessment or not. Again, open source tools, we ended up fixing a lot of bugs in those tools, customizing them to our requirement, or completely scraping them and writing our own scripts. So we did this for a few projects, and then we realized that this is not the way in which you can do a structured process-based security assessment. You need some automation so that the researchers can focus more time on actual analysis rather than fixing issues and making things work. Like you will be, let's say you have a security assessment of 2 weeks. Out of those 2 weeks, 1.5 weeks, you're only trying to figure out how do I communicate with this mobile phone over 5G, and plus there are some new IoT protocols which are being used within the device. So it just doesn't make sense. It's not scalable. So basically what we were looking at is to see if there is a Swiss Army knife that is available, or is it possible to create a Swiss Army knife for IoT security assessment. We're still not there, but we looked at a lot of things, and every tool has their own set of use cases. So, and combining all of them, would be more of a hacky job, where you have a web front end and then you're running all these tools to do different things which have different output. Just doesn't make any sense. So then we started working on the Exploity framework with the same idea that it should have wide coverage in terms of different protocols that are used in different industries or verticals, and all of this should be through a single interface, whether it is radio communication, whether it is communicating with the hardware, or whether it is communicating over the network with a device or the cloud. So that's an open source framework. It's available on GitLab. This is also available as a Python package. Just works on Python 3. If you need to install it, you can just directly run pip3 install Exploity, and it will install the framework for you. If you want the latest version, then you can clone the GitLab library and start working on it. If we have time, we'll probably I'll show you some screenshots and maybe the tool working. So how does it look from a high level overview? It's pretty simple. It's not a complex framework as of now, because there's not much complex functionality in the framework as of now. So you have the framework also comes with a command line tool, which you can use for running the plugins from the command line. Basically, it has two major parts, which is the interfaces and the protocols. In the protocols, you will find standard protocol implementations for some of the IoT protocols like MQTT, COPE, BLE, and for some of the protocols, we are piggybacking on existing Python packages, which we are going to change over time as new versions of the protocol come in. And then there is a test group. So basically, if you were to create your own plugin, all you need to do is just inherit from the test class and use the interface which you want to use. So when I say interface, this will typically be, okay, I want to use serial COM or UART interface. Obviously, you will need a hardware device to do that, but the software capabilities are already there. And specifically for UART, for example, there are a lot of tools available, cheap tools available. They're called USB to TTL. We have some tools on our website that you can use to do specific analysis of the UART communication to the device. And if there is anything specific or in the device that you are testing, you can customize a plugin and basically add your business logic based on what the communication, high level communication is over the serial port. Alright, so how does a plugin look like? A plugin basically has three parts, as you can see, and again this is very, very simple. The most of the work you will be doing in the last part, which is the business logic, obviously, because that is going to be specific to your use case. So you have, what is the plugin about? So basically that's all English. You have what are the requirements for the plugin from the user, which are basically arguments. You define the arguments and the kind of data that you want, and then is obviously your business logic on what specifically you want to do for a plugin. So let's say it's a plugin to connect to a BLE device and send some data over. So you will use BLE protocol, import BLE protocol here, and then define what kind of communication you want to do over BLE. So for example, in BLE, typically you have something called as characteristics. Basically, they are, think of them as information exchange for BLE devices. So you define a characteristic, and the device can either, you can either write a characteristic value to the device or read a characteristic value from the device, or both for a specific characteristics. That is typically how a BLE device in short communicates. So anything that your device is sending you over mobile application, it's the same thing. Anything that your mobile application is sending to the device is using the same terminology. So these are some of the plugins that are already available in the framework. For example, as I mentioned, BLE, we have BLE scanner, we have read, write and fuzz characteristic values. These are the, since characteristics are the only way you would communicate with the BLE device, we came up with a nice misuse case of fuzz testing these characteristic values. So typically you would read a value or write a value to the device to see if the behavior changes on the device and whether you can read some sensitive information from the device. But interestingly, it turns out that you can also fuzz test those characteristic values. It is, the values are not part of the BLE protocol or the BLE stack. The values are, or the character, the values are defined by the manufacturer of the product, or the product vendor. And these values will be interpreted by the application that is running on in the firmware for a specific use case. So in a fitness watch, the developers of, let's say if it's Xiaomi fitness watch, the developers sitting in Xiaomi will decide, okay, this is the format that we are going to use for communication for time. So if you want to set the time from mobile application, this is the format that will be sent to the device, and the firmware developers will then parse that and use that to set the time on the device. And that is where the problem starts, right? Because it's not part of the protocol, it's implementation specific. And so interestingly, if you start fuzzing these characteristics, you will see interesting results. So we've tried it on a bunch of BLE devices, and sometimes we'll find a reboot, sometimes we'll get memory corruption, crashing the device, stopping the device. Sometimes we'll get the device turning into firmware upgrade mode, and there are a lot of different interesting results. Then we have MQTT. MQTT is a very famous protocol. I think if we have time, we will. I'll talk about a bit on MQTT protocol as well, and we can use those that knowledge in the plugins, MQTT plugins that we are going to use. So you have the capability to publish, subscribe, and do brute force authentication cracking on MQTT service. If the MQTT service is on AWS, then you can also interact with AWS service, MQTT service, or MQTT broker as it is called in MQTT technology. Then you have Modbus for PLCs. You can communicate with the PLCs, write register values, read register values, and so on the PLCs. For CAN, if you are connected to a CAN bus, you can read CAN bus, you can write to CAN bus, you can also fuzz values on CAN bus. DICOM is a medical protocol specifically used in all of the hospitals. This is typically a way in which your MRI machines or X-ray machines or whatever will send data to a central server for a specific patient. So it has, it has the image information, the patient information, and so on and so forth. So we have some basic plugins to communicate with the DICOM server. Then we have COPE. COPE is another interesting protocols which is used in some of the IoT products, and this typically works on UDP, but pretty much a stripped down. You can think of it as a stripped down version of HTTP, where HTTP is text based. This is more on using the same logic but binary based. For network discovery, we have MDNS, UPnP, and plugins for COPE, BLE, and ZigBee, where we can discover devices on these different protocols. They are specifically different plugins. I'll show you the plugins in the framework here. Then we have ZigBee plugins, which enables us to sniff, replay, and scan ZigBee networks. Now, again, the thing here is that this is a software. This part is open source. Right now, it is using our ZigBee device. By the time we were writing the framework, there was a well-known open source ZigBee assessment tool called Killer Bee, which had hardware and software. The only challenge was that it was in Python 2, and our platform, our framework is in Python 3. So we kept waiting for the authors to upgrade it to Python 3. Well, that took a lot of time. So what we did was we created a ZigBee module of our own, and you can use that to do the ZigBee operations here. But the idea is that given any well-known open source or famous hardware tool which is used in IoT security assessment, our aim is to be able to create plugins to be for researchers to use it through the platform. There are two important aspects to it. From a researcher perspective, it becomes very easy for you to just buy whatever tools you want, and then forget about how you're going to use the software for that tool, because otherwise you'll end up having a lot of different tools. Just go to Exploity framework, connect the device, and run the plugins for that specific hardware. That is the aim that we or that is something that we aim to do. Same is the case with the debug port scanner. As of now, it works with one of our tools, but again, there's no limitation in terms of adding new debug port scanners implementation in the framework. On the serial, as I mentioned, if the device has a UART port open, then you can brute force the communication. You can even fuzz test the communication. Typically, what happens is, apart from standard Linux embedded devices, some of you would usually see a default shell when you access the UART port on the device. There are devices which will run non-Linux OS with customized consoles, and even Linux OS with customized consoles. So when you try and hook into the UART port on the PCB, you will be interfacing with a customized console. And again, the interesting thing with the customized console is that they are not security tested as much as open source tools, and that's where you can find a lot of memory corruption issues in the custom consoles. So this is again coming from our experience. When you try and brute force, you find hidden commands in these devices which escalate your privileges, or you can cause memory corruptions by just fuzzing the custom console based on what kind of CLI it is giving you. Then for if you have flash chips on the hardware, if you have I2C EEPROM chips on the hardware, given a specific connector, which is again cheaply available, you can read and write or extract data from the SPI and I2C chips. As of now, these two, the SPI and I2C are dependent on a third-party chip called FTDI, and that is cheaply available everywhere. Not very expensive. You can buy any converter that has FTDI, and it's pretty famous. And you can just connect the FTDI connector with the device and hook it on the USB, and you're good to go. We also make a connector based on FTDI chip on our website, but otherwise there are a lot of different connectors available. So exploits, we haven't put much exploits in this. Again, we don't have too much time and manpower. B, the idea is more to be an enabler rather than creating some quick solution. And there are a lot of exploits that we can put. There are a lot of known vulnerabilities and publicly available exploits which we can add into it. But then it'll again become click exploit, which is what we want to avoid. Rather than what we want to do be is an enabler where you have the target, the interfaces, and what you want to do is to be able to customize this to create your own plugins for specific usage. Yeah, so this is how it looks like. Yeah, once you install it, you get a command line tool called Exploity. There are only basically two commands that you can run: list and run. List will list down all the plugins that are available on in a specific version, and and run. Basically, when you want to execute a specific plugin, you can use this the run command. So there is this command line version which researchers can use, and then the CLI version, and then there is a command line direct version where you can pass the plugin names as an argument to the Exploity, which is quite handy in terms of if you're doing it professionally within your organization, to add this to your CI/CD or smoke test or regression test. You can quickly script the tests and parse their results, and then decide pass fail. All right, a little bit of shameless marketing here. So based on the framework, we are also creating a commercial version. We are right now in beta for this. So if any one of you are interested, I can give you free access to the platform. This is a cloud plus device based platform which utilizes a lot of proprietary code plus Exploity framework as well. All right, so before this, I will quickly show you the platform. All right, some of the things here. The source code, as I mentioned, is available on GitLab. It's given in the presentation, the slide as well. The documentation is available at readthedocs.io. I'll just open that as well. So it's exploity.readthedocs.io. So this tells you about a lot of different things, like how the implementation, the APIs, how do you install, and it's pretty simple. Only thing is, during installation, you just need to have some prerequisites on your machine before installing it, and those are also given based on the OS. So if you're using Ubuntu, you can just copy and install the dependencies. They're just typically 2 or 3 dependencies: libusb, libglib2, Python setup tools and stuff. And once you have that, yeah, then you can go ahead. If you're doing it for development perspective, I've copied these commands here. You can clone the library, go into the directory, and yeah, just run Python virtual environment and source bin activate, and then you can go ahead and test the framework. And then if you any changes that you make, you can just keep reinstalling the framework within your development environment. Otherwise, if you're using it, not developing on it, then you can just install the dependencies and then just go ahead and do pip3 install Exploity. That's it. Yeah. All right. So, for example, here I'm already in the development environment. Yeah. So let's say you want to run a specific plugin. So now you're charged with assessing a product, and suddenly you see, okay, this thing uses MQTT. So you go about quickly reading, okay, what is MQTT? How does it communicate? And then you identify, okay, in MQTT there is a service in the middle, and the way you communicate is you publish application messages, and you subscribe to something called as topics, and that's the way you communicate. And now you want to go ahead and see, okay, what are the topics that are available for subscribing, or what is the backend information that you can get, which you can now quickly go ahead and run the MQTT plugins. So let's say you want to see what a subscribe plugin does. So just run -help. It will give you, obviously, this is what is defined within the plugin. Like, what does the plugin do? What does the plugin require? So in this case, let's say we are going to subscribe. So let's subscribe to, there is a specific a wildcard hash which is used as a wildcard for topics to subscribe. I'll talk about MQTT after this, but I'll just give you an idea. So what we need to do is we need to specify the host. There is a test server that Mosquitto runs. So Mosquitto is one of the very famous MQTT brokers or service, open source service that is available, and they run a test server for developers to use that service to test their own endpoints. So let's say I just want to subscribe to a wildcard, and yeah, that's about it. I think timeout default is 5, so let's keep it 5, and let's see if this let's keep it for only 3 seconds. Hope it works. Right. What? Yeah. All right. So yeah, I'll give you a brief idea about MQTT protocol. I'm sure you're not with your laptop, so hands-on would not be possible. So instead, what I'll do is, let's talk about the MQTT protocol, and then you maybe will get a better idea. All right. So we'll quickly try to cover these things. I won't go into much detail, but just give you an idea of what we're dealing with. MQTT has become one of the very famous IoT protocols, which is used in consumer electronics as well as now getting into industrial IoT as well. So this is short for message queuing telemetry transport. It's a very lightweight messaging protocol. The way you would communicate over MQTT is you publish data, application data, which is you're sending the data out, and you subscribe to something called as topics. So you publish on a topic and you subscribe a specific topic or multiple topics, and when somebody publishes on that topic, all the subscribers get the data from the service or the broker. We'll see how that works. This is an ISO standard as well. So you can read the standard specification itself. Very simple, not a complex protocol. So as I mentioned, there are topics and topic filters. So this is how a typical topic looks like a directory structure without starting slash here. And this is application dependent. The manufacturers will define what kind of topics they'll be using. If they are using AWS, then AWS defines some topics, and then you can create your own topics as well and define the meanings for them. And each of this is called a topic level, separated by a topic level separator. So there are two wildcards. One is multi-level wildcard and one is single wildcard. Multi-level wildcard means wherever you put this wildcard, it means any topic at this level and any of the child levels as well. So if you have, for example, multi-level wildcard here, it means pi2/office/a/b/c and anything inside those. All of them are applicable. And single level wildcard is the sign is plus, and it means only specific to that topic level. So if you specify a plus here, it means all the topics that have pi2 followed by anything followed by boardroom and temperature. Yeah. And the standard itself defines that any topic that starts with a dollar character should not be used by applications, because it is to be used by the backend or the service for control APIs or whatever. And this becomes a handy start point for you to do assessment of anything that is using MQTT protocol. Alright, so this is how a typical MQTT system looks like. You have a broker in the middle, and the job of the broker is to do nothing but pass messages from one place to the other. And this broker, typically, if you're looking at AWS, for example, or GCP or Azure example, your broker will be sitting on the cloud, and all these clients are either end devices or mobile applications. So yeah, devices can subscribe, devices can publish. Let's say 3 devices subscribe to a topic A/B, and A/hash, which is a multi-level wildcard. And let's say this particular client publishes on A/B. Now out of these, only the right 2 nodes will get the message, because the one on the left hand side is subscribed to a topic A, which is a single level topic itself, whereas the message is published on A/B, which means these two nodes will get that message. So that's how typically your communication over MQTT happens. And yeah, so then MQTT defines 16 control packets in the latest version, which is version 5. And again, the format of the protocol, again, I'll not go into deep, but it is very simple. You have a fixed header, you have a variable header, and you have a payload. And this will be, this is basically this whole is an application payload which works on top of TCP. So yeah, your fixed header will define what kind of message is this, or type, if you will. And so the type defines the different kind of messages or control packets, whether it is a connect message from the node, whether it is an acknowledgement from the broker or the node, whether it is a publish message, publish acknowledge message, subscribe message, unsubscribe message, and so on and so forth. So variable header is typically, as the name suggests, variable in length, but used for things like packet identifiers, where you want to identify request and response. So I send a publish message, I get an acknowledgement with the same identifier, and so on. And then finally you have payload, which is application dependent, which is where the application data goes in publish, for example. Yeah, and then there is return code. Think of return code like HTTP response codes, which tell you whether there was a success or an error. Yeah. So again, connect is the first thing that you would do is, once your TCP connection is established with the broker or the service, you would go ahead and do an application connect or an MQTT connect. In this, you would specify the version of the protocol and whether you want to authenticate. And this is what we use to brute force the authentication for MQTT service. Publish again is the same. You specify what topic you want to publish on and what is the application message that you want to publish in the payload. Subscribe is when you want to subscribe to a single topic or a list of topics or a list of topic filters. So within the payload, you would define a topic filter and its subscription options, and this is a multiple tuple. So multiple topic filters and subscription options. And then unsubscribe. Now, some of the standard security issues with MQTT protocol is it gives a lot of information when you're doing reconnaissance on the service, unless it is protected. And again, these protocols are new protocols, so none of the or most of the brokers or services which are non-standard or your own implementation typically will be open to reconnaissance, where you can find more information. Password cracking, because it's part of the connection. Even if you implement authentication, people can still brute force the authentication. Then there's no stopping that. And one of the, I'll come to that interesting factor later, corrupting the sys data. So typically you would find $sys data available to any node that is connecting to the service. And then some services will also allow you to write data. And this is important backend data, not application specific data, which means you are messing with the broker backend itself. Injecting malicious telemetry data. This is pretty interesting from the perspective that we have tried it with multiple protocols. This has nothing to do with the protocol specifically, but what happens is that the data that goes, telemetry data that goes from the device to mobile application or to the cloud, is ultimately converted into some other form where it will be used by either the mobile application or a web application, which means even though, let's say, you're using MQTT, the data that you are passing could effectively exploit a web application. Let's say you could, if the data is being put into a standard SQL database and the application is processing it, you could pretty much, as a malicious node, connect to the service and instead of putting in correct data, put an SQL injection data, right? There's no stopping. If the application reflects that data back to the users, you can pretty much inject an XSS payload, right? So there is nothing specific to MQTT here, but what you're trying to do is you're moving into a different protocol domain and try and exploit that. Same is the case with cross-protocol attacks. Then is denial of service. There is one specific DOS technique that we found in almost all implementations of MQTT. The problem is that there are two things when you connect to an MQTT service. One is the authentication, which the implementations may or may not do, and one is client ID. So there is a slight confusion in terms of how do you identify a client. Ideally, if you're doing authentication, you should rely on username as the identity for the device. But most of the or some of the implementations that we have seen is client ID is used as an authentication to authenticate the node as well as identify the node, which is wrong. So basically, if there's no authentication, anybody can come and say, hey, I am client foo, client ID foo, connect to me. While we were trying this, we figured that the protocol itself has this weakness where the implementations, even though they are adhering to the protocol, what happens is if there is a client ID connected, let's say the client ID is HITB and doing some work, and then there is a new client that comes up, connects with the client ID HITB. What happens is the service looks at, are there any clients with the name HITB connected to me? And if they are, it disconnects the old client. So basically, if you know the client IDs or you know the algorithm to generate the client IDs, because it's not a secret, right? If you know what implementation the nodes are using, you can pretty much figure out how to generate client IDs. And what you can do is, if you have an MQTT ecosystem, you can just start brute forcing with a specific with these client IDs. All right, so I don't think we'll be able to do hands-on since it needs a laptop. But what you can do is go to exploity.readthedocs.io. The documentation is available there. We have a YouTube channel. In that YouTube channel, we have some videos explaining how do you go about installing it, how do you go about using it, and then protocol specific plugins which can be used. And we have you can also go on our website exploity.io. There's a bit of information about the open source, bit of information about so we have an online store. If you're interested in IoT security, we sell some stuff there. And if you're interested in contributing to the open source framework, you can send me an email. I'll just show you my email as well. All right, let me just quickly give you a demo for the banner grabbing on MQTT, so that you have an idea of what I'm talking about. I wanted to do the hands-on on how do you go about creating your own plugin, but I'll show you. There is a sample plugin available within the framework, which you can open and look at the code on how it is implemented and then change it according to your needs. But let's quickly first do this. So if you're using or if any service or product is using Mosquitto, or typically anything that adheres to Mosquitto, $sys, topics, this might be exposed, which means it will tell you so now I subscribe to a specific topic, which is broker backend topic. and version, which will always give me the software name and the version of the software which you're using. All right. So about the framework, once you do a git clone, you'll get a exploity directory. Just go inside another exploity directory, and then you have the core directory which has the core implementations. You have the plugins directory which has all the plugins. So if you want to look at how one specific plugin is implemented, you can go in that and look at the code. And all the plugins are just arranged in terms of their respective technology or protocols. There is one called sample.py, which is, we've just kept it as a sample, which does not do much, but you can look at the code and pretty much see the format for how you would go about defining your own plugin. So pre and post functions are not needed. You can eliminate them. Execute is what is your business logic, and then for logging anything on the framework, you can use output handlers or tlog functions, where you can print on the terminal as well as log data in JSON format. So then you can go ahead and change and add it to your so I'll just change this to show you the name. Let's say I'll call it sample new summary, and here what I'll do is I'll go back and I'll install this back again, and then I'll run Exploity list, and the sample is part of COPE. This one. So you can quickly prototype your own plugins. Just go ahead, edit the code, reinstall in your development environment, and test what the plugin does. All right, let me go to. Oops. So yes, this is the website. Sorry. .io. All right, yeah. So we are running Black Friday sale as of now. Just FYI, you have the online store. We don't have the product, the platform details in here. If you want to go to this is where the platform is deployed. If you're interested in looking at it from a professional perspective, I can give you access to the platform. Basically allows you to run automated firmware scans, automated debug port scans. You can pretty much do Zigbee, sniffing. Everything is then managed on the cloud. So basically this is the idea behind this is to create a platform for security compliance testing for IoT products as well as vulnerability management. So you're not only getting compliance in the platform, but you can also do full-blown vulnerability management for your products, for your or your customer products. And if you are interested, or if your company is interested in this, you can send me an email on these email IDs, and any of these email IDs, and I'll be happy to give you beta access.